In October 2017, humanity found something moving through our solar system that shouldn't exist. And then, before anyone could get a real answer, we lost it forever. It came from nowhere, moved unlike anything natural we'd ever tracked, sped up when physics said it shouldn't, showed no tail, no ice, no dust, and then vanished into the dark, never to be seen again. Scientists pointed telescopes at it, some pointed radios at it, listening for a signal. What they found instead was silence. And that silence is the part nobody talks about. On the night of October 19th, 2017, an astronomer named Robert Warwick was sitting in front of a screen in Hawaii, sifting through images from a telescope called Pan-STARRS, when he noticed a single point of light behaving in a way that made no sense. It wasn't orbiting the sun. It wasn't looping back the way every comet and asteroid ever recorded had looped back. It was moving in a straight, hyperbolic line, coming from one direction in deep space and heading toward another, using our sun only as a brief pit stop on a much longer journey that had nothing to do with us at all. For the first time in the history of astronomy, humanity was looking at an object that had been born around a different star entirely, and had traveled across the emptiness between star systems to arrive, uninvited, in ours. They named it Oumuamua, a Hawaiian word chosen deliberately, meaning something close to a messenger from afar arriving first. And that name would turn out to be far more accurate and far more unsettling than anyone expected at the time. Here's where the story should have been simple. An interstellar rock passes through. We take a few pictures, we log the data, we move on. But almost immediately, the object refused to behave like anything astronomers had a name for. When it was first spotted, researchers assumed it was a comet. Comets are the objects that typically arrive from far distances, trailing ice and dust as the sun's heat boils material off their surface. But Oumuamua had no tail, no glowing halo of gas, no visible plume of dust catching the sunlight the way every known comet produces one. It looked, in every visible way, like a bare rock. So the label flipped. This must be an asteroid, then. A solid chunk of rock and metal with no ice to sublimate. Except asteroids don't typically arrive from outside the solar system, moving at 87 kilometers per second. And this one did. Think about what that means. Within days, scientists studying the exact same object couldn't agree on which category it belonged to, because it was showing properties of both and behaving fully like neither. That's not a minor classification dispute. That's the first sign that something had shown up that didn't fit any box humanity had built. And then the shape came into focus, and the story escalated again. Telescopes couldn't directly image Oumuamua. It was far too small and far too distant for even our best instruments to resolve as anything more than a point of light. But as it tumbled through space, its brightness flickered dramatically, brightening and dimming by a factor of about 10 over the course of hours. Astronomers know exactly what that kind of light curve means. It means the object is wildly elongated, roughly 10 times longer than it is wide, tumbling end over end as sunlight catches its long face and then its narrow edge. No natural asteroid or comet in our own solar system had ever been observed with proportions that extreme. Some analyses suggested a cigar-like shape, stretching between 1 and 400 meters long. Other early estimates, based on different reflectivity assumptions, suggested something closer to a flat, disc-like pancake, several hundred meters across and vanishingly thin. Read that again. Scientists studying the same small patch of light in the sky couldn't even agree on whether they were looking at something needle-shaped or saucer-shaped. That's how little we actually understood about the thing that had just entered our neighborhood. But here's where it gets worse. Oumuamua's surface was reddish, the kind of deep, weathered color astronomers associate with organic material that has spent hundreds of millions, maybe billions, of years being irradiated by cosmic rays in the vacuum between stars. In other words, this object wasn't newly formed. It had been drifting through interstellar space for an almost incomprehensible length of time, absorbing radiation, aging in total darkness, long before it ever crossed paths with our sun. Whatever solar system it came from, whatever event flung it outward into the galaxy, happened so far in the past that pinning down its origin became close to impossible. Astronomers tried anyway. Based on its incoming trajectory, they traced its path backward and found it seemed to be arriving from the general direction of the star Vega, in the constellation Lyra. It sounded like a clean answer, the kind of detail that closes a case. Except it wasn't. Vega wasn't anywhere near that position in the sky 300,000 years ago, which is roughly how long it would have taken Oumuamua to travel from there at the speed it was moving. The trail led nowhere. The messenger had no return address. And then, just when the story seemed like it might settle into mysterious but ultimately natural, the acceleration data came in and everything changed. As Oumuamua swung past the sun and began heading back out into deep space, astronomers tracking its position noticed something that should not have been possible. It was speeding up, not by a huge amount, a tiny, barely detectable extra push, roughly 5 millionths of a meter per second squared. but speeding up nonetheless, in a direction that had no business happening under gravity alone. Now, this alone isn't unheard of. Comets do this all the time because as ice on their surface heats up and boils away, the escaping gas acts like a tiny rocket thruster, nudging the comet's path just slightly. Case closed, right? Except Oumuamua showed no visible outgassing whatsoever. No coma, no dust, no detectable gas, nothing a telescope could see to explain where that thrust was coming from. And when scientists modeled the way the acceleration behaved over time, it wasn't the rough, sputtering, unpredictable pattern you'd expect from chunks of ice boiling off unevenly from a rotating, tumbling surface. It was smooth, consistent. The kind of acceleration curve you'd expect from something being pushed by a steady, continuous force, like, for instance, sunlight itself pressing against a surface with an enormous area and almost no mass. This is not a small detail. This is the moment the entire story stopped being a footnote in an astronomy journal and became one of the most heavily debated scientific controversies of the decade. Harvard's chair of astronomy at the time, Avi Loeb, looked at that data and reached a conclusion most of his colleagues were not prepared to hear out loud. Working with a colleague, Shmuel Bialy, he calculated that if Oumuamua were extremely thin, somewhere between 1/3 of a millimeter and less than a millimeter thick, then ordinary sunlight reflecting off its surface could explain the mysterious acceleration perfectly. No outgassing needed, no exotic new physics needed, just an object built with an almost impossibly large surface area relative to its mass. The kind of structure nature doesn't build. The kind of structure engineers design when they build something called a light sail, a spacecraft propelled not by fuel but by the gentle, constant pressure of starlight itself. Loeb didn't stop at hinting. He said it plainly. Oumuamua's shape, its lack of any cometary material, its improbable thinness, and its trajectory, one that happened to bring it on a close pass by both the sun and earth, were all, in his words, consistent with an artificial object, a derelict, possibly a piece of technology, drifting and tumbling, dead or dormant, sent out from some other star system by some other civilization, long before it ever reached us. And this is where everything changes, because once that idea was on the table, the entire scientific community had to respond to it, whether they wanted to or not. The counterarguments came quickly and they came hard. Other researchers pointed out that a light sail thin enough to explain the acceleration would have to survive an unimaginably long journey through interstellar space without being shredded by dust and gas along the way, and when physicists actually ran the numbers on how fast such a sail could realistically travel, they found something that gutted the deliberately sent version of the theory. At the speeds Oumuamua was actually moving, reaching us from even the nearest plausible star system would have taken roughly 500 million years. 500 million years of drifting, unpowered, exposed to the full violence of the galaxy, on the off chance it might one day tumble past a random star with a rocky planet orbiting it. That is not a targeted visit. That is not a probe with a destination. If it's artificial at all, most scientists who engage seriously with the idea concluded it's far more likely to be abandoned debris than an intentional messenger. A piece of junk, not a spacecraft with a mission, but ruling out deliberately sent didn't rule out unexplained, because the natural explanations kept failing their own tests one after another, and that failure is exactly what kept the mystery alive. Some scientists proposed Oumuamua might be a fragment violently torn away from a larger body during a close encounter with its home star, a chunk of debris stretched and reshaped by tidal forces, the same way our own moon would be torn apart if it strayed too close to a black hole. Others proposed something even stranger, that Oumuamua wasn't solid rock at all, but a colossal iceberg of frozen hydrogen, so fragile and so reflective that sunlight alone could push it exactly the way the data showed. And so fragile, in fact, that it would have slowly evaporated during its journey without producing the kind of visible tail regular comets produce. Still others suggested it might be something closer to a loosely bound dust bunny, a fractal aggregate of ice and debris so porous and low density that it behaved unlike any solid object ever catalogued, its structure held together by little more than static-like cohesion, thin enough to respond to sunlight the same way a sail would without needing to be artificial at all. Every single one of these theories required inventing a type of object humanity had never directly observed before. Read that again. To explain Oumuamua naturally, scientists didn't reach for something already in the astronomical record. They had to construct entirely new categories of object. Never before seen physics of ice, never before seen densities, never before seen formation processes, just to make the numbers work. That's not how confident science usually sounds. That's the sound of a field genuinely uncertain, quietly patching over a gap it can't otherwise close. And while all of this was unfolding in papers and conferences, something else was happening in the background that almost nobody outside the field noticed at the time. And it deserves far more attention than it got. In December of 2017, while Oumuamua was still just barely within reach of our instruments, The Breakthrough Listen initiative, a privately funded program dedicated to searching for signs of extraterrestrial technology, turned the massive Green Bank telescope in West Virginia toward the object. For 6 straight hours across 4 different radio bands spanning a huge range of frequencies, they listened. Not metaphorically, literally. They pointed one of the most sensitive radio receivers on the planet at Oumuamua and searched for any signal that might indicate the object was emitting something artificial. Anything with the strength of even an ordinary cell phone transmission would have been detectable. This is the part almost no one explains clearly when this topic comes up. Humanity did check for a signal. We had the capability, we had the motive, and we pointed our best equipment directly at it while we still had the chance. And what came back was nothing. No transmission, no artificial pattern, just the ordinary static of empty space. Now, think carefully about what that actually means, because it cuts both ways, and that's exactly why the mystery never fully closed. Silence doesn't prove Oumuamua was natural, a dead or dormant object, debris drifting for 500 million years, its power source long since exhausted, if it ever had one, wouldn't necessarily transmit anything at all, whether it started as a piece of alien hardware or not. But silence also doesn't prove it was ordinary rock. It simply means that if there was ever a story behind Oumuamua more interesting than tumbling ice or a fractal snowball, that story wasn't going to announce itself to us with a radio signal. Whatever the truth was, it was going to have to come from the physical data alone, and that is precisely the data that ran out. Because here's the part of this story that turns it from a scientific puzzle into something closer to a tragedy. Oumuamua did not linger. It was never going to. It swept through the inner solar system in a matter of weeks, passing the orbit of Mars in early November of 2017, crossing Jupiter's orbit by the following May, sailing beyond Saturn's path by January of 2019, and continuing outward ever since on a trajectory that will eventually carry it past the outer edge of the Kuiper Belt and, by the year 2038, across the heliopause, the true boundary where our sun's influence ends and interstellar space truly begins. It was only close enough, only bright enough, only observable at all, for a narrow window of a few short months. And that window has been closed for years now. Right now, as this is being said, Oumuamua is somewhere beyond the orbit of Neptune, a cold, dark, tumbling shape too faint for any telescope on Earth or in orbit to detect, receding further into the void with every passing day. No spacecraft was ready to chase it. No follow-up mission was possible. The single most anomalous object ever detected in our solar system arrived, refused to explain itself, and left, permanently, irreversibly, before we had the tools or the time to understand what we were actually looking at. Scientists studying it today are blunt about this. The honest professional consensus is that we will likely never know, with full certainty, what Oumuamua actually was. Not because the question was abandoned, but because the object that could answer it is gone, and it is never coming back. There is no return trip. There is no second sample. There's only the data we managed to gather in a handful of frantic weeks in 2017, and every theory built since then has had to work from that same small, incomplete, permanently frozen dataset. But this is where the story widens, because Oumuamua's disappearance did not close the book on interstellar visitors. It opened a much bigger question about how many more of these things have already passed by us unnoticed, and how many are still coming. Less than 2 years after Oumuamua vanished, astronomers caught a second interstellar visitor, an object called 2I Borisov, discovered in 2019. And this time, almost frustratingly, it behaved exactly the way a comet should. A visible tail, clear signs of outgassing, chemistry consistent with material from another star system, but nothing shaped like a needle, nothing accelerating without explanation, nothing that broke the rules. In a strange way, Borisov's ordinariness made Oumuamua's weirdness stand out even more sharply. It proved that interstellar objects can and do pass through our solar system, and that when they do, they usually look exactly like what we'd expect. Oumuamua wasn't weird because interstellar visitors are inherently strange. It was weird because, out of everything we've now seen, it was the one that refused to fit the pattern. And there's another episode worth knowing, because it shows exactly how easy it is for this whole conversation to go wrong in either direction. In September of 2020, astronomers spotted another object on a strange, seemingly natural-looking trajectory, initially suspected of being a possible fourth interstellar visitor. For a moment, speculation started building all over again. Then researchers dug into its details and discovered the truth was far less exotic and, in its own way, far stranger. It wasn't from another star system at all. It was a discarded rocket booster from a lunar mission launched by NASA back in 1966, still drifting through space more than 50 years later, doing a slow, ghostly orbit that briefly mimicked something interstellar. It's a small story, but think about what it reveals. Even our own space junk can momentarily fool the very tools we use to search for visitors from other stars. That's how thin the line is between unexplained and misidentified. And it's exactly why the scientific caution around Oumuamua, refusing to declare it either definitely natural or definitely artificial, isn't hesitation. It's discipline. And the search hasn't stopped, it's accelerating. In July of 2025, astronomers detected a third confirmed interstellar object, now designated 3I Atlas, spotted by a survey telescope in Chile and confirmed within the same day by the international body responsible for cataloging objects in our solar system. Unlike Oumuamua, which came and went in a matter of weeks, this new visitor is expected to remain observable from Earth well through 2026, giving scientists something they never had the first time: actual time. Time to point every available instrument at it. Time to measure its composition, its shape, its behavior before it slips away. Researchers are already comparing its properties directly against Oumuamua's, hunting for any sign of that same impossible acceleration, that same absence of a tail, that same refusal to fit a category. So far, it appears to be behaving far more like a conventional comet, but the fact that we now have the luxury of watching closely, in real time, is itself the story. We are, for the first time, getting a genuine second chance to study something like Oumuamua while it's still here to be studied. Meanwhile, scientists haven't stopped trying to explain the original object using newer tools. As recently as early 2025, researchers published detailed numerical simulations modeling the kinds of solar systems capable of ejecting an object shaped and behaving like Oumuamua, testing scenarios involving systems built around a single giant planet, and modeling how the violent tidal forces near a star could shatter a volatile-rich body into an elongated, rocky-surfaced fragment with an icy interior, a structure that might explain both the strange shape and the puzzling acceleration without requiring anything artificial at all. It's one of the most convincing natural models proposed so far. And notice what that phrase actually admits. Most convincing so far is not the same as solved. Nearly a decade after Oumuamua vanished into the dark, the very best natural explanation science can offer is still framed as the leading theory, not the final answer. So where does that leave us? It leaves us with an object that arrived from a direction that doesn't match any known point of origin, built in a shape nothing in our solar system resembles, radiating an age measured in hundreds of millions of years, accelerating in a way no visible force could explain, checked for signals, and met with total silence, and then gone. Permanently, unrepeatably gone, before a single one of those questions could be closed. It leaves us with a roster of scientists who spent years constructing entirely new categories of physical objects just to keep the natural explanation alive, and a minority who never stopped arguing that the simplest fit to the data was also the most uncomfortable one. And it leaves us with the uneasy knowledge that we now know, for certain, that objects like this exist, that they pass through our solar system more often than anyone assumed before 2017, and that the only reason we're now watching a third one in real time is because we finally started looking properly. What was Oumuamua? Was it truly nothing more than an ancient, tumbling shard of interstellar ice, shaped by forces we've only just begun to model correctly? Or did humanity, for a few unrepeatable weeks in the autumn of 2017, have its telescopes pointed at something built by hands, or by whatever passes for hands, that did not belong to us, and let it pass by without ever getting the chance to ask it directly? We checked for a signal once. We got silence. We may never get another opportunity to ask again, unless the next one that arrives decides to stay just a little bit longer than the last.